Okay, it's 9th of July 2025 and today's Leetcode problem 3439 3439. Reschedule meetings for maximum free time, and it is the first part. That means there is a second problem advanced, certainly, where we are required to reschedule meetings for maximum free time. I'm suspecting that will be tomorrow, 10th. But back to the problem. So today, you are given an integer event time denoting the duration of an event, where the event occurs from time t equal to 0 to time t equals to the event time. I think that is clear. You're also given two integer arrays, start time and end time, each of length n. These represent the start and the end time of any non-overlapping meetings. We are going to see what that means. So, where the ith meeting occurs during the time, from the start time to the end time, of course, it would be happening within that. So you can reschedule at most k meetings. So you might have a series of meetings, but you're required to reschedule a certain number of meetings, which they are calling k meetings, by moving their start time while maintaining the same duration. So you cannot compress or dilate the start time or the duration, but you can shift the meeting time here and there. So the goal is to maximize the longest continuous period of free time during the event. So the relative order of all the meetings should stay the same, and they should remain non-overlapping. Yes. So what do we want? We are required to return the maximum amount of free time possible after rearranging the meetings. So that's the question. Basically, you have meetings, time slotted, and you need to space them. So if we come to our canvas here, if we pick up the pen here, you could have a meeting, let's label this 0, 1, 2, 3, 4, 5. So if we have two meetings of duration, maybe 2 to 3, and maybe 4 to 5. So from 2 to 3, you have that meeting, and then from 4 to 5, you have that. So these meetings, if we are to reschedule them, they should not, like the order shouldn't change. That order should remain the same. But I wanted to give you a clue about how these time slots are. And our goal is to maximize these, yes, to maximize these free spaces such that we have plenty of them as we reschedule k meetings. Okay, so let us look at the problem. We have looked at the problem, but let's try to understand it more. Could do away with everything here. Now, in order to get a basic explanation of what is happening here, is you have an overall time window, and this is like you have from 0 to the event time. Okay, inside there are n non-overlapping meetings. Within that event time, there are n non-overlapping meetings, and that means you have the start and the end. That's what it means. So you may take out, for example, you can reschedule up to k of those meetings. So you can reschedule up to k meetings, keeping each one's duration fixed. And so the duration must stay fixed, and slide them anywhere you like within that term. You remember this? Yeah. So you can slide these meetings anywhere you like, as long as you keep the duration untouched and you keep them non-overlapping. So after your moves, you want the longest single stretch of time during which no meeting is happening to be as large as possible. So you might end up with something like this, maybe. And this is not to scale. So, but the idea is that basically. So we need to grab some key insights from here. I could just slide over the canvas without deleting, but I love deleting anyway. So coming back to key insights, what do we get? If you can guess, the key insight here is the gaps. So we need to define gaps between and at the end of the meetings. Now, if we denote gaps as by G, and the first gap we want to reason out is G0 or G1, G0. This will equal to the start, and that is the first start synod minus 0, because we start at 0. Like when you start, the duration is 0. So we want to look at those contiguous free time windows. That's the goal, and we are going to form an array of those gaps. Once we have an array of gaps, we can then decide which meetings we can shift in order to maximize these gaps. Now, if you want to have or to generalize, GI would basically equal to start of I minus the end of I minus 1. You've nailed it. And that is for if we are looking at 1 less than I less than n minus 1. Remember, this is an array, and we want to look at the last element. That's why we are having n minus 1. So let me see. Okay, this is not working. All I want is to move this. Yes, got it. For G, that means we've looked at GI. That's not really like generalized, but that means for a particular gap I, we've nailed it. Okay, you get it? Okay, I can shift things. Yes. So for GI, we have the start I and then the end I. But what if we want to generalize this to GN, which would be the event time minus the end, which would be n minus 1 in that case. So that means there is a particular number of gaps that we can form from any schedule here. That means there are n plus 1 gaps within a particular set of meetings, so to say. So that means the gaps would be G0, G1, G2 up to Gn, and we've looked at what Gn is. So initially your free slots are exactly these gaps. So the free slots that we have are those gaps, and whenever you reschedule a meeting, two things happen. One, you remove it from its original slot, which effectively merges two adjacent gaps into one big gap, because you've taken out the meeting between them. I don't know if that makes sense. Whenever you reschedule, you're effectively merging two adjacent gaps. Like there is a gap here and here, and so if you reschedule one of these or this, you're merging two gaps into one, and that's what is happening. Then another thing that happens, you insert it somewhere else, chopping up a gap at its new location. So when you insert it somewhere, you're chopping up a gap at a new location. That's what is happening. So what would be the optimal way to maximize a single free interval? And that's where we come in now. But the optimal way to maximize a single free interval is one, pick one contiguous run of k meetings to remove. Yes. So you're going to pick meetings. Okay. Yes. So I was saying we need to pick a contiguous run of k meetings. Contiguous would mean in this case those meetings that are adjacent to each other, maybe like that. So after picking those meetings that you want to move, like we've discussed previously, this merges k plus 1 gaps that surround them into one big gap. So incidentally, you end up making the k plus 1, like you add an extra gap of those adjacent gaps, you add one more gap. And so you reinsert those k meetings outside the merged region. And that means the best free time you can get is exactly, and this is where the most important thing is. So the best free time you can get is exactly the sum of k plus 1, consecutive gaps. And this word is important, consecutive gaps. So that's the best free time you can get. And what would be the algorithm here, or the approach that you would take? You guessed it, the sliding window. But this sliding window is over the gap array. And remember, we are forming an array of gaps. So you build a gap array G of length plus 1. So array G, and the length of G is n plus 1, because it begins from G0 or G0. And we need the maximum sum of window size k plus 1. We have talked about that. So the window size will be k plus 1, and that is window size with my Android. Then concretely, if you index gaps from like G0 up to n, then for each I equaling to 0 to n minus k, you want to look at the free space or the gaps, and this could be for each, like the free I you are looking at. I need to create some space here. Would be summation, or like we want to sum up from j equaling to I up to I plus k of g, whereby the index is j. I hope this makes sense. Remember, we are looking at these gaps and we are summing up from that given gap up to there would be the kth, but we are stopping at n minus k. So essentially we are adding that I plus k. So we have these initial gaps, and then we are adding that extra gap. But these gaps must be consecutive, and that is important. So that's literally the algorithm. And one important thing is to note that you need the maximum of like if you have this interval from I 0 less than I less than or equal to n minus k. So the maximum of that is what we at the end of the day want. So maybe at the end of the day, we can, before we dive into the code, we can look at the complexity, whereby while you're constructing this G array, it is the big O of n, because you're computing the n gaps, and that's O of n. And then when you're computing the sliding window, whereby you're looking at the sum of the length k plus 1, this is also O of n. And overall computation time and space time, O of n, which is time, and you have space, which is we can say O of 1 if you do the window in one place. So we are looking at O of n as the complexity. So let's dive into the code and talk about this. Okay, so for our code, what we want is one, we want to define n, int n, the integer n. And what is n is like the size of this array, and this equals to the start time given here, start time. And because start time is a vector or an array, we want to look at its size. So these are the number of meetings for within the array that we are given. We have n. Now we want to look at the edge cases. What would be the edge case? Edge case we have, or the edge case would be if k is greater than n, or greater than or equal to. That means you can remove all meetings. The entire time is free. That's what it means. Like if the number of meetings are greater than the size n, you can literally remove all meetings. So that means we have if k is greater than or equal to n, so you return the event time. Okay, I think that is very direct. Now, the next thing we want to do is to build the gaps array of length, which is n minus 1. So build the gaps array of length n plus 1. So the gaps within any particular element, we've said the gaps I, this equals to free time between meetings. And the gaps, the 0, we've talked about this. So let's go. I usually love this std vector. And when we look at the computation, because these meetings can get large, when you look at the restrictions here, what's the event time? Yes, this is n to power 5. Like the constraint is n can even go to power 5. So for me to be on the safe side, I want to the data type to hold, I'll put long to be safe. And these are gaps, and gaps, we've said the gaps array would be of n size plus 1 as the size. Okay, so the first element within this array is the start time, definitely, and we're putting that as the first element within our vector here, and that makes sense. Okay, and that is the time before the first meeting, ideally. So for the integer, int I equaling to, we are iterating from 1, like the first, then the number one element, and we are going to see why we are iterating from 1 is because we need to subtract from that element that comes before 1, which is the 0th. So we can't start from I equaling to 0. We want to start from I equaling to 1. I hope that makes sense. So I less than n, and we want to increment it, of course, and then we get out of the loop. We would find the body. So we want to create our array. So the gaps I, every element within I. How should it be formed? This should be the start time. If you've seen this, then you got it. So the start time I, that's why we're starting from I equaling to 1. That will be like the 0, then the first. So we've left one element behind. But then we want to subtract minus, of course, the end time. But that is I minus 1. Okay. That's how we form these gaps, the gaps array. And with that, but I want to be safe, I want to cast a long here, the long, such that our value is within the constraint. Okay. What is this? Okay. So we have the gaps array or the vector, and the n, the gaps of n would be the event time minus, we've already defined this in we've looked at, well, let me first write it down. Event time minus the end time of n minus 1. That's like the last element of the gap for particular n. And this is free after the last meeting. This is free time after the last meeting. And the next thing that we want to do, we want to initialize the sum of the first window of size k plus 1. I hope that makes sense. Another thing here, we need to cast the long. Okay, so we want to define the window sum now. And because this is long, we want to say window sum, because we've defined the gaps and our sum comes from the gaps. So we want to say for int I equaling to 0, okay, I less than or equal to k, y less than or equal to k, because somewhere we said that our sum is k plus 1. Okay, coming back, like the gaps that we need to add up. Increment I, because it's a loop, and then the window sum would be the sum of the gaps of I. Yes, so you're adding those elements within the gaps array up to k plus 1. Okay, and yeah, that's all there. So I guess now everything is long. So we want to define the value, the best sum, which is calling to the current window sum. And then we want to slide the window from I equaling to 1, I equaling to n minus k. At each step, and we need to add gaps like I plus k and subtract gaps I minus 1. And this is what we need to do, is a for loop, as we know, int I equaling to 1, I less than or equal to n minus k. Okay, increment I, and then we have the window sum equaling to, it's an addition, equaling to the gaps of what I plus k. Okay, then we have the window sum, which is a subtraction of the gaps from I minus 1. Okay, and then the best would be the maximum value between the best and the Windows sum. This is a maximization problem. So at the end of the day, we now near our solution and we want to return best. Yes, best there. So we want to test. In order to be safe, I want to cast this back to an integer, and let me run that and see. We have an error which is less than k. This is I, not 1, and I think I've done it in many places. Okay. That didn't work as planned. Let me check. I guess I've done some mistake somewhere. Okay, this is I equaling 2. Someone has already seen the problem. I think there is a problem there. Let's do this again. Okay, voila. So this passes. Let's see if we pass all the tests, and wrong. We're failing some tests. Okay, it could be the. I'm going to review this in the next part. Thank you guys for watching. Please subscribe to the channel and leave a like, leave a comment. Yeah, like I solved this here, and yeah, I'm going to see where the problem is, and I'll give an extra video about it. Bye bye.